Hello everybody. In this presentation we will talk about how to give movement to a simple robot. This main controller from a fuzzy control that will be executed on the programming language Java. First we will talk about the interaction of all of the components of the system. We have a model that represents a robot. By the fundament of this, the part of the head signs we will use to turn it based on the light that receive the LDR that are located in that edge. The LDRs are connected by a circuit that drives an Arduino card, the same that we can observe to read them through a monitor serial. This data is also read from an app in Java for processing by the fuzzy controller and forwarded back to the Arduino card to write a spin angle on the engine. For this job, Java uses the next libraries. In the whole system, we have two input variables that will be used in the JFuzzyLogic module. These are right LDR and left LDR. In this we have used a Gaussian function for when the light is low and strong, whereas for the average light we use a trapezoidal function. So in this range, the number of values remain constant until a considerable change occurs. As you can see, the same function and range are used for the two inputs. In the right on the display, we can look the code of the JFuzzy library.
The rules we used are those we see in the presentation table. We must take into account that we have considered that as long as the light intensity in both LDRs are the same, we will have an angle of 19 degrees. That is, there will be no turning. For a turn to occur, the intensity of one of the inputs must be greater than the other, giving a partial rotation of 45 degrees. If the intensity of the other input is not completely exceeded, or a total rotation of 90 degrees if completely overcomes the other input. For the outputs, we have put forward 5 Gaussian functions. It is necessary to have a stable control of the system, so that it does not make sudden movements. The Gaussian curves are given by the equation that is in the presentation, where we have that n is going to be the maximum value of each section of membership, and k is the value that is related to the standard deviation of the Gaussian bell, which was given in 50 to achieve a less abrupt control of the system. Below, we present the operation of the robot.
In first place, we look the robot is centered at 19 grades. In this moment, we will give light of the left LDR. The robot turns his head to the left. Now we will give light to the right LDR. The robot turns his head to the left, to the right, and return to the center because the light for the two LDRs are the same. You can observe that we tape the right LDR, the robot turns in a 45 grades to the left. If we light the left LDR, the robot turns in 118 grades and return the before position. It is all for our presentations. Thanks for paying attention.